Hello everybody and welcome to another video of the Coding on VeChainThor series. My name is Michael, but most of you will know me by Mirai83 on various platforms. In this video I'm going to show you the basics in how to interact with the VeChainThor node. So let's get right to it. Before we get started on the live coding session, here's something to remember. If I had known this when I first started with VeChain, it would have saved me a lot of time. The VeChainThor node does not handle private keys. And since it does not handle private keys, it cannot sign transactions. So the node is just a gateway through the blockchain. And if you want to sign transactions or do anything with a wallet, means with a key store or with private keys, you have to do it with a local program, with a local wallet or with your own developed wallet, and then sign the transaction and then send it to the blockchain. This gives the blockchain a very nice touch, so you can basically develop lightweight apps in JavaScript and run it on a browser, and then those apps will send signed transactions through the blockchain to whatever blockchain is available, if it's public or if it's private hosted. And then the blockchain will just transmit the transactions and check the transactions and put them in the transaction pool, so the authority nodes can sign them, can put them into blocks. The only way to interact with a VeChainThor node is via HTTP GET and HTTP POST, because it has a Swagger API, which I'm going to explain a little later. And this is the only way you can interact with it. And also to remember is that every response of the VeChainThor node is in hex. So you basically have to transform everything into decimal or whatever format you like. So after that being said, let's jump right to the live coding session. For this, I'm going to just get back to the VeChainThor Linux node we installed in another video and check this again. We can check here that we have a Thor node running, as you can see here. And for the interaction, I'm going to check for the IP. And this should be, where is it? This one. This is the IP of the node. And as I said earlier, the port on which the node runs is 8669, so 29.5156. Now we're going to switch to a browser. And basically, I already opened it to test if it works. We type it inside this browser. As you can see here, the full HTTP and just enter this, and then we get this in response. So we can see it's a Swagger API, it's a RESTful API, which is pretty awesome. So everything is XML or JSON, so you can just get the data and transform the data and put data into it. Sorry, and just work with it. But before we do it in an XML format, we will just explore what the options are via the web browser. So if we scroll down here a little, you can see there are different options we can do, and this is basically pretty awesome if you're just getting started, because you don't have to know any commands, you don't have to know where you're going, you just can simply browse a little and see, and that's exactly what we're going to do. The first thing we're going to do is check the blocks. So you can see it's a get command, and I can click on this, and there is a basic description of what this command does, and there's also a try it out button. And then we scroll further down, and here you can see we can insert a block ID or a block number. Since this is our local node and it's not fully synchronized, we don't have access to all the blocks yet, but only to the blocks that are already downloaded and processed by this node. Since we don't know what block this is, we can just put in best in here, and this will load the best block this blockchain node has. So we're going to execute, and you can see It's pretty cool. We also get the curl command for this, what we just did, and we can use this later. And this is the actual response that we got for this block. The best block in this blockchain, blockchain node, is 2,520,514. And we're just going to execute the command again, and you will see this value will change. Yeah, it's now higher, and if you do it again, it's now even more higher. That's because the blocks are getting imported pretty fast, because it will get up to 8 million and something. And we're just going to click execute again until we have a transaction here. Fine. So as you can see, we have a block number, a block ID, and all the information about this specific block, including a transaction ID, but only a transaction ID. So this is basically the just the basic information about this block, and this is how every block looks like on the VeChainThor mainnet. And if we also want to have the information about this transaction included, we can do a little, we can do the query a little different. To get the exact same block, I'm going to copy this block number, put this in here. I can zoom a little more. Oh no, that's fine. Put this block number in here, and we want to expand the block. Set this on true. And now we're going to execute again. And as you can see here, the curl command now has changed. It gives us the exact command which will return this information down here. So we're now querying a block, and we set it to expanded equals true. And now we get the same information as before, but also we get the information about the transaction that is included into this block. So we have the transaction ID, we have the chain tag. We're not going into details about every value here, but some important information. We can see this transaction has one clause, this one, and this is the recipient address, and this is the value of that sent to this recipient. From somewhere there should be an origin. Yeah, from this origin, from this sender address to this recipient address, this amount of that VeChain that was sent. As you can see, it's you can't read the number because it's in hex. As I said earlier, everything is in hexadecimal. So if you want to actually read this number, we have to transform it into into the decimal system. To do this by hand, we are just exploring here. We're not doing complex programming in here. We're just exploring the options. We can copy this, open in a tab in the browser, search for hexadecimal, get the first, put it in here, and now we have a very, very large number. The number is so large because VeChain has 18 decimal points. Means we have to divide it by 18 times 10. And to do this, we can simply count. As I said, it's very basic in this video. We post it in here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then we put in a colon here because we're in Europe. And so this value was 55,496 VET. To confirm this, we can just copy this transaction ID and open the official VeChain block explorer. It's on explore.vechain.org, and we can import this transaction ID here and search for it. And you can see, we did everything right. It will show you the transfer of 55,496. It's exactly the same as we did with our manual calculation. So as you can see, the process is straightforward. It's pretty easy to develop programs around this because everything is nicely in JSON, and everything is built in a way that you can easily process a lot of data. And now we're going to get this transaction ID again, and we're going to explore another option on the VeChainThor blockchain. We're going to make this small again, and we can see here we also have transaction points and transaction options that we can call. So we're going to try it out again and put our copied transaction ID into this form and say execute. And as we see again, we get the curl command, which is pretty awesome to get started, and the response of this blockchain, of this transaction. Since we already know the values, we're not going to convert them again, but now we have the information about this specific transaction. We can see again a transaction ID and one clause. If we have multiple clauses in this, we can simply they will be simply in this window, and the transaction code can be pretty long. And we can also check, this is basically the blockchain data that was sent to the blockchain, and we can now check what the blockchain made with this data. For this is the receipt option. I'm going to post it in here too. Oh, damn it. There is the transaction ID. And we're going to do it again. And we can see the output of this transaction actually was from sender to recipient. This amount of VAT was sent, so it was a legit transaction. It's also said here reverted equals false, so it was not reverted. This is the VeChainThor reward that was generated for the authority node that signed this transaction. And this is the amount of VeChainThor paid by the sender for this transaction. The values differ because 70% of the gas will be burned, and basically this is 30% of this value. So now we already checked, we also checked the transactions, and let's just grab this this address. This is a sending address and this is a recipient address. It doesn't matter which address we take. We're just going to copy this address and also querying the address option. So if we put our address in here, we can see that the blockchain will return a balance and energy. Balance is VAT and energy is VeChainThor. But since this blockchain node, this node where we are interacting with, this node, our own node, is not fully synchronized, this is not the amount of VAT it has right now, but the amount of VAT it had with this block with the best block it had right now. So if we do this again, okay, it's not going, but the energy is changing right now. If you take a look, it's increasing. That's normal on VeChainThor because every VAT generates VeChainThor. So when we import 1,000 blocks, the energy value will increase, of course. And with this, you can basically query everything in the blockchain. It's basically all you need on these three gets, and also some posts up here, but that's not for the basics. And if you want to transmit a signed transaction, you can simply put it in here. There's the basic code and what it has to look like, but we're not going to do this today. We are going to write a very basic program now on the blockchain, on the Linux node, to show how you can automate some options with the blockchain. For this, we are going to get the block and take best in here and copy this command right here. And now we're switching back to the actual node. Let's clear this. Come on. And we're just pasting it here. but we're not going to expand it. We just want the easy mode. So if we do this, yeah, the node is busy. It takes a while. Come on. If we do this, we can now see that the blocks are increasing, but there's also a lot of data around these blocks. As I said earlier, it's all formatted JSON, so we can make it pretty to make it easier to look at. For this, we're going to use a program called JQ. It is already installed on this node, but if you want to install it, it's just apt-get install JQ, and it's already done. And now we can just use our command from earlier, put a pipe in there, and just do JQ with behind it. And now you see everything is pretty. It's very easy to read, and we can repeat it, and you can see the block numbers are increasing, but there is still this up here that we don't need. So we do a curl with a -s for silent. So these options disappear also. Now it already looks pretty cool. And the thing we want to do with our basic program is we just want to check for the blockchain, for the block number. This up here, this one. And since we're already using JQ, we can just put in number in here. So we just querying number. And you can see we now just get the number of the blockchain in return. That's already pretty cool. And now we're going to write a very basic bash program without inside the command line. So we're using our command here, and before this I'm going to put while true. This basically means as long as you don't interrupt it, just do stuff. Do. Then we're going to do the exact same command we did before. Then we're going to sleep 1 second, and then we're done. And if we query this now and let it run, you see the command will run every 1 second because we defined this in here. And just query the newest block on the blockchain. And now you can see we're actually seeing now there are 7 blocks. Now it's getting pretty slow. This normally means that there are big blocks to be imported. And we can run this as long as we want. Of course, this will only make sense for a node that's synchronizing because we only have 1 block in 10 seconds, so we don't need this to be repeated every 1 second. And to show you a fully synchronized blockchain node, I will query another node. As I said earlier, I provide public VeChain nodes for development for the community, and we can just do this. mainnet.vblocks.net, and if we do this, we can see we are querying now the fully synchronized node, and it will not change that often because we only get a new block every 10 seconds. And we're now on block 8,161,166, and we cannot, of course, we can also do other scripts with other queries with this script. If we switch back to our Swagger API, we said earlier that we can query addresses with this script. And I've prepared one address. Let me get this. Yeah, we will query now this address. This is the hot wallet from Binance. It's a very well-known address, and no one is specifically into this address because it's basically a public address everyone knows. So we're going to import it there and query what we have to do to get the information on how to get an address information. And now we can do this, copy this, get back in here, post it in here, and as you can see, now we get this in return. We get balance, we get energy, and we get hashcode, which is no. Hashcode will only be true if it's a smart contract. So now we're going to put again JQ behind it. This will already make it pretty. We're going to ignore the curl overhead, and we're going to query the balance. As you can see now, we have now only the balance of it, or we can just query energy, and now we have the energy value of this address. Now we're going to write our program around it while crew do this, then sleep, I'll say every 5 seconds, and then we're done. So we're now going to wait for the next block, and that's already awesome. So we can see if you query it every 5 seconds, it's already done again. Oh, that's nice. Okay, we're querying. I was wondering why it's changing every 5 seconds. Every 10 seconds. It should be every 10 seconds. But we are not querying the synchronized node. We are querying this node, and this node imports all the blocks, so it will change more often. So we're going to remove all of this and put this in here. And now it should change every 2 repetitions, means every 10 seconds. And the next one, yeah, now we can see with the block changed, the energy has increased, and we can now transform this. We are just going to need, come on, okay, never mind. We're just going to copy this into our hex converter and remove these one, and now have an even bigger number. And we will also do this by hand by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then do this, and the energy on this Binance hot wallet is about 187 million. So now we're going to check this again on the VeChain Explorer. And you can see if we put those right underneath, it's since there's already more blocks, it has increased, but our values are correct. And this is basically how you do all the queries and all the information on the VeChain blockchain. I'm going to show you another detail on how it looks if you query very big blocks. For this, we have to first find a big block. Since you only can query blocks and you have to know where you're going through with this Swagger mode, I'm going to use a little tool that I made myself. It's vblocks.net. It keeps track of the VeChain blockchain, and we can choose a big block if we want to. So this is from today. Today is Saturday. There are normally not that many big blocks, but it doesn't matter. There's a block, 8,158,000. I have to write this down. Okay, already closed Notepad. 8,158,000. 8,158,000. And doesn't matter, they're all big. 534. 534. So we're going to copy this and put this inside our block query. Just put it in here. No, this will not work because it's not the mainnet node. We should go to vblocks.net and then query this big block. And as you can see, there are a lot of transactions in the block, but since we have not set it to expanded, the response is pretty small. And once we do this, you can see there is a lot of information in this block. We can scroll, you can see the bar here. We can scroll for days. I will actually download this just to show you how many lines are in here. Okay, yeah, okay, what's could be so easy. Okay. will do it. And I'm going to open this in here. And you can see now, if we zoom in a little, there's all the information in it. And if we scroll to the very bottom of this node, you can see in this block there are 13,000 lines in this. So it's a very big block of information that needs to be processed, and this is why the VeChain node has to have some power with it, but it's also being processed pretty fast, so it doesn't have to be overpowered, but we have to have decent hardware specs on it. Okay, this is it for the basic information, for the basic access with the VeChain blockchain. I'm going to switch back to this. Again, thanks for watching. I hope I can see you in another video, or you can contact me on Twitter or anything else. If you have any questions about this video or anything VeChain dev related, you can join our Telegram channel. All the awesome VeChain devs are in there, and we will guide you in the right direction. Thanks for watching, and hope to see you again soon. Bye-bye.